The 2 by 2 by 2 meter box could also be represented with a point cloud. If it were scanned out in the field, there would be an array of points that covered all surfaces of the cube in the form of a list of x, y, and z coordinates. This list would be extremely expansive and contain coordinates anywhere from x equals 0 to x equals 2, y equals 0 to y equals 2, and z equals 0 to z equals 2. The point cloud could be written mathematically as a list of 3D points, where each point has coordinates somewhere on the surface of the box. This box could also be defined using tessellation. The most common approach to storing a 3D object using tessellation is with an STL file, which defines the object in terms of triangular facets. Each of these triangles needs to have 3 vertices and a normal vector stored. The coordinates of the vertices give information on the triangle's location, and the normal vector indicates which side of the triangle is the inside of the object and which side is the outside. The normal vector should point in the direction of the outside of the object. The simplest representation of our box using tessellation would break each face up into 2 triangles, resulting in data representing 12 triangles. For the bottom face, the first triangle would have the first point at 0, 0, 0, the second point at 0, 2, 0, and the third point at 2, 0, 0. It would have a normal vector of 0, 0, negative 1. The second triangle would have the first point at 0, 2, 0, the second point at 2, 2, 0, and the third point at 2, 0, 0. It would have a normal vector of 0, 0, negative 1. The tessellation could be written mathematically as a series of T's and V's, where T represents each triangle's coordinates and V represents each triangle's normal vector. An example for the first triangle and normal vector is seen here. Another common method of tessellation uses cubes as the elements rather than triangles. This application is often seen in computational fluid dynamics, CFD. When creating 3D models for CFD, 3D space is defined as a set of 3D elements, usually cubes. The collection of cubes may be referred to as a mesh. If we were to use this method to represent our box, the number of cubes we need would depend on the size of cube defined as an element. For this example, let's use 1 by 1 by 1 cubes as elements. To fill a 2 by 2 by 2 cube, we will need 8 1 by 1 by 1 cubes. In this version of the tessellation, the box can be described using the 8 vertices of each 1 by 1 by 1 cube. These vertices give all necessary information about the size, location, and orientation of the cube. For example, the first cube could be described by the vertices shown here. This pattern would repeat for all 8 cubes, giving us our 2 by 2 by 2 box.